while loop in a language which doesn't have any support for loops. Okay, and someone pointed out you can use regression. Okay, so how is a while loop? D sugar 2, it's D sugar 2, something like this. Okay, so don't worry about these numbers. I basically have a global counter that keeps on giving them adding numbers to these things because they won't get conflicts. So while 2, okay. Yeah. So here, before you can assign something, that actually bind that variable in the code language. So select y2 equal to undefined, and then execute this piece of code. And then y2 equal to identify this function, and then call the function here. Okay. So what is this function doing? This function has a. We forget about try, but let's look at this piece of code. If I is less than 0, apply print. I'll talk about apply later, but it's basically calling saying print I, and then I equal to I plus 1, and then call y2 again. Okay. When you call y2 again, what happens? So when you say I equal to I plus 1, it's actually updating the I in the scope above. So when it tries the same condition. So if this false, then it says none. It won't call it recursively again. Okay. So this is how for while loop is implemented in the code language. This is how it's distributed in the code language.
Just a little late. So what's the reason for that? You are doing it as an undefined and then.
So that's actually goes back into the implementation of the interpreter. Okay. I didn't show how the interpreter is implemented. Okay. Except there's only this is the core language syntax. But the interpreter actually, if you see, it took 3 arguments. It took an environment and a store. So the way environment is designed is so when you try to assign something, okay, it expects the binding to be there, and that is only of creating a new binding. When say x equal 1, doesn't create a new binding. Okay, that's how it's implemented. Okay, why it's implemented like that? That's actually turns out to be very easy to implement that way. So when you say let x equal 1, then say x equal x plus 1. Okay. So the first collab, that's a C leg, that actually creates a new binding. And then that x equal x plus 1 is actually reassigning something. Okay. So in my core language, it turns out to be, let me go back to the core language and show what it means. Okay. So in the core language, this is C leg. How is this implemented? You evaluate this value, add a new binding. Simple. And C set, it takes the ID, finds existing binding, and then set. Replace that with this value. Okay. Now there are 2 different operations. Okay. But if I had to have assignment x equal to 1 to work, then I have to combine these 2 operations as a single thing in the core language, which kind of becomes hard to implement. So this actually needs separation between those 2. So adding a new binding is different, and reassigning something is different.
So CLET is the only way to create a new
CLET is that's the only way to create, but when you call a function, it automatically, when you call a function, it already sets those bindings before it executes that piece of code.
Okay. Which bindings?
So when you call a function square x or x into x, x into x. So when you call square of x, binding for x is already created.
Oh, okay, for the arguments.
Yeah. So C app creates a binding and C let creates a binding. Okay. And there's another creating binding in C here, but I'll show you. Okay. So that makes things completely separate. Okay. Now you see. Okay. Now, how do I implement a break? You see, the while implement as a recursion. Okay. Now, how do you implement break? Okay. Break implement like an exception, like an error. Okay. So now, in the whole piece of code, if there is any error of type break, okay, then don't do anything. Just come out. Okay. So same way I can implement continue. Okay. So I'm using the label of my C error. So C error is a way of raising errors in the code language. So what it says is, this is the label of the error and this is the error value. So I'm using different kinds of labels for implementing the language. So this is all decided in the desugaring step, not in the code language. So desugaring says that use break as the label here. And when you want to do a real exception, I use error as a label. So I basically have 4 different types of errors I'm using. One is return, one is break, one is continue, one is error. Okay, so all these things translate to the same feature of the code language, error handling. So I don't have to really worry about implementing all these things in the code language. Just visually takes care of all of it. Is that clear? Any questions? Yeah. So now let's see. So it's actually couldn't show you. He didn't fit. So it's actually this is a for loop. Okay. So what? So I thought that so it's for loop. So for I in range 10 print I, how will that get reissued to? It actually gets reissued something so big. Okay. So if you see here, it first gets an iterator first, like what I showed in the macro for to while macro, and then inside this, it's actually seeing how exception handling is done in the core language. Okay. So
but you said for loop is again converted to while loop. Right?
yeah, but and the ambition of the while loop there, that gets to core language, right?
Yeah.
That
So this is the same as the what is the difference between this guy and the previous one?
okay. So talk about macros.
Thank you for
Yeah.
that.
Yeah. So now, so I'm saying that this is equivalent of this. Okay.
Yes, yes.
So what I do is, when I want to desugar fur, I don't desugar fur. I create a call a macro. What it does, it takes fur and converts it into while loop. Okay. And then I desugar that while loop.
Okay.
Right. So now this function gives me takes a for loop and gives me a while loop. That's Python code, right? Now I'm translating that. So eventually I need to translate that into core language. Right? So I call desugar step again.
Yeah.
So it takes the while loop and then desugars the whole thing.
Yeah.
So that becomes what we are seeing. So you take the for loop, run the macro, that gives you while loop, and then desugaring on that gives you the core language code. Okay, that's the code that we are seeing here. It's not fitting here. Okay. So let's try to see how exceptions are handled. Okay. So if you see that it should try and then say next of iter, and then what it should do, it should accept stop iteration. Okay. So what the accept stop iteration means? If the exception of type stop iteration, but of type is not there in the core language at all, right? So now the core language doesn't understand anything about classes, objects, inheritance, and all these things. So when you raise, say accept stop iteration, it doesn't really mean anything in the core language. So you need to translate that to make something meaningful. So what it does is, it try and accept. So this is the core language try and accept. Take the error as exe value. If the exe value is an exception of this type, then do this piece. Otherwise, raise the same exception. Okay. So the try and accept is implemented. It's basically implemented as desugaring. So this piece of code is actually try I equal next of iter and accept stop iteration and break. That's what. So you see previous code. That's what this actually. Yeah. So if you look at this piece of code. So I'm implementing try accept stop iteration break. So this how will I implement? That's what I'm showing you in on this slide. Okay. So now try is next of iter. In the core language only have if error, right? So that's try except predicate is error. So take the error. So the label is error. This piece rises an error of label error. Take it as ex value and execute this piece of code. Otherwise, don't do. Otherwise, say none. Okay. Now, what is this piece doing? Now, try and accept in Python. You can specify what class of exception you want to handle. Okay. Since the core language doesn't know that, what we do is we have to write code to actually do that. So what it does is if underscore bool is basically converted to boolean. If this exception is this type, so I have a built-in function is exception, x exception and the type, and then tells you is of that type. That's of that type. Then take that as e and then so it's a break. Right? Break means raise break, and it doesn't have any exception error value, so it's a none. That's how exceptions are issued, and then the remaining while piece of thing will come. That's the core part of the implementation. Okay. So I don't have more slides, but I'll show some of the examples and how it works. So that's basically the whole implementation picture. Okay. So, any questions so far? So I'll want to go and tell you like what are hard parts in my implementation. Okay. What are the things which are difficult to implement? So, but these two steps are the core of the implementation. So one, you have a core language and interpreting to the core language, and then you have a desugaring. So it takes the Python AST and then converts it into the core language. And everything else. So you have a bunch of built-in functions like underscore bool, underscore is exceptions. That builds the whole implementer. The hard parts are two things. One is implementing the Python scoping. I haven't got it right. Okay. And there are some still bugs in my implementation. And implementing the class structure. The core language doesn't know anything about classes. Now, how do I implement classes, inheritance, and all this thing in the language? Okay. Core language doesn't know anything about it. Desugaring. So basically, so what we need to do is when we say a.x, what should happen when we say a.x? Right? So that should get resugared to something more meaningful. That basically gets resugared to. So I'll basically show you some of the examples to understand it better. So now I have a
I have one question. I don't know.
Yeah.
When you say core language, probably mistake. Is it the data structure that you have designed, or is it scheme?
No, it's a data structure that I designed.
So why can't your code language define classes? Because
I can.
it's abstract data, right?
No, I can. Core language even can define even for loops. Okay.
Yeah.
But thing is, I wanted to reduce the complexity as much as possible. Okay. So now the design, the whole design approach that I've taken from the beginning is we have a very small, simple core language. Okay. The core language is very easy to reason about how it works and all that. Okay. And then everything else gets translated to the core language. Okay. So now it's actually better to actually keep the core language as small as possible.
But if the implementation logic becomes so explosively big,
Okay.
might as well define a new type, a class type, and
No, but actually I'll show you how class is implemented. Okay, it's not very hard. Okay.
okay. Sure.
So now in my core language, it has objects. It doesn't have any anything. So let's look at the core language syntax. Okay. So this is the core language. It's like the data types I wanted to show. Okay. So these are the data types that I have. I have primitive values. So I have undefined null, number, string, vector, and a function. Okay. And then I have an object. Object has a primitive value, class, and a dictionary. Okay. I can actually make an object out of anything. Okay. Say it doesn't have any primitive value is null, and then class is say 1. I mean object representing number 1, and then say dictionary empty. Okay. So here the core language doesn't stop you from actually creating a class where class is not really a class but a number or a string or an exception or whatever. Okay. So because it's designed like that because we want to keep the core language as simple as possible. Okay. So you see it's actually more like a JavaScript-like thing. Object has a prototype. That could be any object. So it's more like that if you see. Okay. Now, now actually if you take the same core language and actually implement JavaScript on top of this. Okay. So it's called surface syntax. So you have the core language interpreter, and then you can implement different kinds of surface syntax to it. Okay. In fact, it can actually be multiple languages. One Python, one JavaScript, actually running on the same core. So that's a whole idea. So you should keep the core language as simple as possible, but make sure that you have all the features that you need. So it should be explicit enough to implement all those things. So I was showing. Let's say take A equal to X. Okay. So how does this work? So I have a make desugar. What it does is it executes that, it prints the desugared outputs. Okay. So that becomes get as X. Okay. Now my class implementation goes into this function. Okay. When say get attribute X, where should we get from it? We should first look at the object and then look at the class and then its base classes and all that goes into implementation of this function. That's not part of the language. It's not part of the language at all. That's part of a built-in function. Right? That's much easier to handle than putting that into the language. Okay, so let me I think the problem text. Let's say we have this code. Okay, let's see how this gets issued. So because it was too big to have for loop and all that, so let's actually try to understand, or rather, I'll put an inference example. So except exception as E, and then say wait. Let's say this is our code. Okay, let's see how this gets issued. Here, right? Alright, let's let me put both of them. Okay. So now, try x. Okay, this basically does x and then accept error as an exe value. That's a core language. So this piece raises any of this, then it executes this piece of code. Okay. Now in that piece of code, it takes exe value and checks if it's a type E exception because that's what I've asked it for. Okay. And then I said the exception as E. Now this block of code should have access to a new binding called E. How do you create a new binding? Should say let. So let E equal exe value and then apply. So apply is the call the function. Okay. Otherwise, if it's not of this type, what should I do? I should raise the same exception back. Right? So I should if I raise stop iteration here, well not an exception but something else if I raise, then it should actually not go here but the exception should be raised back. So if it's not any of this, then should raise the exception again. So that's a built-in function that raise. Okay.
What's exe value?
So that's okay. So I should show you the core language. Okay. So the core language. So core language has a concept called if error. So what I'm showing you is a predicate of the core language. So if error I'm showing you as try and accept the predicate. Okay. So if error takes a body of all these things. Okay. It executes this body. If there's any error in this piece of code, what it does is okay. So let's see what an error means. So look at C error. This is how you read. This is you are raising errors in the language. So error has a label and an error object. Okay. Say error foo 1. Okay, foo is a label and 1 is the value of error. If error, what it does is it executes this body, and if there is any error of this label, E label, what it does is it executes E body. Okay. Before execute E body, it binds the error to this label. E label. So that you can use that in the body. Okay. And then or else is else in the. Okay. So that's how if error is supported in the core language. Now if you see the core language, so this is basically I'm desugaring it to, okay. So desugaring is taking the core language, the surface language, that's a Python language, and converting it to core language. So it takes the error and calls it exe value. This is the label that variable name I have used because I use a hyphen because that's not a valid variable name in Python. So you can use that. That will never conflict with anything in the user program. So even if you see the while, I say while hyphen 1, while hyphen 2, because that will never conflict with anything user writes. Okay, and then so now I know that there is an error. Okay, now it is but if exception of this type. Okay, then I should check if the exception is of that type. So is exception actually implements that logic, then convert to boolean. And because if in the core language only treats one as truth, everything else as false. So if you pass a list or something, then this function actually converts it like that. Then since as E, I should bind it to E and then execute that piece of code because you might be using E in this piece of code. That's how it's issued. Now let's see how. So someone asking about list comprehensions, right? So the X for X in range 10. Okay. So this get issued with a list of map. Let's say the function taking one argument that X equal to undefined and say take X equal to arg1. So this is done. I'll explain why I'm doing this, but let's assume that you're getting X as an argument and then return x into x. Okay, you take this function, and then, so basically call range with 10 as argument, and then apply. So basically desugaring this comprehension into a call to a map function. Okay. Now, I mean, there could be for x comma y, right? And then it's possible to have a list comprehension which takes multiple values, right? Okay. So this gets desugared to something. So it has two values x and y. Okay. So that value 2 is argument. Then yeah, it's basically so what it does is it does a multiple assignment here and then execute a piece of code. Okay. So that's all done in the desugaring part.
How do you implement the X range if I want X range?
Huh?
How do you implement the
Okay, this is Python 3, there's no X range, there is range. Okay. So you want to say how range is implemented.
if
Okay.
I have to implement something in memory,
Sorry?
if I want to implement something that yields result.
Okay. Oh, so I'll actually show you my implementation of range. So it's implemented. I'm going to range in Python itself. Okay. So what I'm doing is yes, the insurance and all that are just to make sure the behavior is exactly same as range. Okay. So it's a class takes 3 arguments. Okay. And when you convert a string, it does these things. And say iter, it returns a range iter with all these arguments. And this is a range iter. Okay. So many of the features of Python language are included in Python itself. So this is the bootstrap for this actually executed before anything is executed. So if you see, so in my code language I defined objects for all the classes, string, integer and all that, okay. But actually the implementation of all that is here, okay. So if you see, yeah, if you see these exceptions that we have seen earlier in the exceptions, okay. It basically checks if class is none or that's the instance of that, okay. For example, you can just say except without any class, right? So you see this, okay. But I can just have let's say except, okay. The class will be none here, okay, because there's no class given. So what do I do? So you just pass none as these exception, and that takes care of that. Which is complicating this code. So that's a function, okay. And then so I have defined all this.
Looking at the instance.
Yeah. Is instance. You see where is instance?
No, that's your implementation, no?
It's actually implemented in this. No, this actually, I started with this, but we implemented that in the backend itself. So this is not there. So what I do is I have I've defined all the classes in the code language. Just define the classes, okay. Dummy, skeleton classes, class for int and all that. And then I initialize all of them in Python itself. For example, this is a class for string, setup string. Set the class for name is str, implement underscore equal to and all these functions. You want to do when you multiply string with something, make sure it's integer, and then you add multiple times and then return. So if you see, my core language has data types only this number string and vector. That's all I have. When I could have put a dictionary and all those kind of things in the core language, but I choose not to do it because just to simplify the implementation. Here, the motivation is not to make it fast or anything. The motivation is to finish. I mean, just do it. Okay.
So how was your dictionary implemented? In Python, or is it? You implemented it in Python.
See.
Okay.
That's our dumb implementation. Okay. Because the point is not to get dictionaries fast or something, but just to get the language right. And okay, how do you think of implemented lists?
in Python itself?
Yeah. So now, so Racket doesn't have a data structure which can change its size, resize itself. Okay. Only it needs to append some things. Okay. Now it has only vectors of fixed size. So I've used it for tuple. Okay. So what I do is I create a tuple and then store the tuple, and then I mean tuple doesn't let you change the value, but I can throw a backdoor change its values. Okay. I mean tuple doesn't let you change the value, but through a backdoor I can change its values. So what I do is I create a tuple as data and put a size. So whenever you append something here, okay.
You create a new one.
So if it's already full capacity, then double the capacity. So basically, create a new tuple of the same capacity and then add it gets double, and then I set data and then do all that. Okay. So your list is implemented in Python.
So all these underscore things are there provided by the
No, these are built-in functions I have written.
built functions things implemented in Racket.
Yes, some of them was implemented.
This list you could have implemented in Racket also, right?
I could have, but Python is more easy to write. So the thing is, even if I write, I have to implement it in the same way. I translate this into Racket, okay? Because Racket doesn't have a way of a data structure which has
You can use
elastic
that
capacity.
recursion to always get the new list. Like for example, add, right?
Yeah.
So append. Okay, I will give a list. So you have the old list and the new list, and you always return the updated list.
That's not possible because I'll give you an example. Let's say I have A equal to 1, 2, 3. Let's say B equal to A. Let's say you dot append 4. Okay.
Yeah.
Let's say print B. What do you expect?
Yeah, this is the appended one.
Appended one. Okay. But so now the same object should get modified. You can't give a new object, right? So what
No,
was
so okay, in your case, right, this B and A will be having the same ID or no?
yes,
Right?
that's the same point, the same object.
Correct, correct.
Yeah.
So when I'm doing print B, I'm actually giving the A. I mean,
Yes.
the appended one.
Yeah.
Okay. See in your okay, you cannot change. So you have a C symbol, right? So you have a association of symbol and its
Right.
this thing label,
Yeah.
right? So you cannot change that.
I can change. So you're saying that.
So what I'm saying is assign a new list altogether.
Okay. So here, B is what? So you're talking about now. We're getting into semantics of Python, how it works. Okay. So when you say B equal to A, both are actually referring to the same object.
Yeah.
Okay. B is not referring to A here. B is referring to the same object which is referring to A.
Correct.
Now, when you say A equal to append 4, you should modify the same object.
Yes.
But what you are suggesting is you can replace it with a new list.
Yes.
Okay, so but then it becomes a new object, right? So
B will point to something else.
Yeah.
B will point to the old.
so B will still continue pointing to the old one. So it's like saying that A equal to append list will come 4. That's what you're suggesting. Okay, you could create append and create a new list and then assign it back to A. But we will continue pointing to the old one. So that's not the right semantics. Well, so the thing is, you can say that that's the easiest thing that I could do to get everything. We had just 2 months time to do all that. Okay, and it's actually 3 months course, and the first month of it, I didn't pay much attention to in class because there's PyCon going on, and I was doing a Python training, and I had a lot of. I had to do my job, and so basically, the first month really didn't pay much attention to the class. Then second month, I started implementing the Python interpreter. Okay, so really I had to learn all those things again. So it's like in 2 months I had to finish these things. So the best thing is to get things done as easy as possible than to. I don't see it as a hack. Okay, it's the right thing, but that's it. It might not be as very efficient. That's fine because we're really not doing it for a production quality thing. We're just doing it for the sake of implementing an interpreter. Yeah. So the hard parts are getting the scoping right. So you can actually have you can have local, non-local, global implementations. Okay. So how do you do all that? Okay. Let me see if I have. let's say if I have this function, okay, how will this be implemented in code language? So now, when I say f equal to x, then f should be a local variable, it should not be a global variable. Right? So how should this work? So what I need to do is I need to look at the body of the function and then find out what are the local variables, and then so when I say make e sugar, it actually becomes okay. So now I need to look at the body, traverse the body, figure out all the local variables, all the assignments that I'm doing, and then bind them first to an NLD file and then use it. Okay. Otherwise that becomes a global variable. Otherwise it goes and tries to set something in the upper scope. Okay. It should not do it. Okay. Whereas if I just say just y, then you will not see y not defined. Then it will see y in the upper scope. So this is a hard part. Okay. You have to actually look at the function and then do all these things. Okay.
So if you had just said def f of x and you say print y.
Okay. So now. F of x. Okay. So not bound white. So it tries to find it.
So it assumes that it's already bound somewhere.
No. So it actually knows. It actually checks if it's a local or non-local.
Okay. So it's not defined inside here. That's basically the thing, right?
Yeah.
It's not assigned to.
It's not the same. Okay. But and basically finds in the upper scope.
So
Okay.
even other things like, for example, if you say for I in range 1 to 10,
Yeah.
print I, and then
Okay.
after that you say return I.
Okay. So yeah. So these are the hard parts.
Okay.
Okay. So we want to say flash I in range
10,
10.
pass, return I.
Okay. Now it's a very big level for loop. Okay. But it knows that I is a local variable and then
So
y is
you
the
got that.
I mean that's a hard part. I have to traverse the whole tree and figure out the local
That's the only
variables.
way to do it.
That's the only way to do it. And that's why it's very, if you actually see how classes are, the behavior of classes in Python, okay. I sent a mail to Bangpypers also, okay. So what happens is, let's now have a function here, say x equal to 1, say class foo, print x equal to print x. What do you think this will print?
One to one.
1 to 1?
Yeah.
It does it, okay. But it's not a function, okay, but it's just a, okay, we'll call it foo here. What can this do? It's not a class, it's just a function. No, it doesn't. Okay. It says x is, you're using x, local variable x before it's defined.
Really?
I won't call it.
Python 3?
No, all. Okay. So unbound local variable x, okay.
Line 6, which line is that?
Line 6 is this one. Okay. Now I had to implement this behavior. Okay, how do I implement? So let's see. Okay. So what does is let's see what desugaring is doing. Okay. So let's look at where it's trying to print x here. Okay. What is x? X is undefined. So when you're trying to look up a variable and its value is undefined, then it says it's unbound local. So that's the hard part, getting the scoping right. Okay. So I mean that's not just that. Okay. I haven't got some things of the class not right. Okay. So now when you say def f, okay, self, you call get x.
Self. Is it
Class.
it's not a class one.
Oh, sorry. I wanted to ask. It's a return X. So, which X should it pick up?
Here it picks up the global X.
Sorry,
X
global X or this X?
X equals 1.
X equals 1.
Okay.
So see, any function when it's defined, it has an enclosing scope. Okay. So now what's the enclosing scope for this guy?
Is the class, definitely.
It's a class. Okay. But it's not. Okay. But the better behavior says that it's not. It should actually bind to this.
Okay.
It should bind to this.
Okay, so
So that's actually
it's ugly, no?
it's ugly. Okay. So no, I couldn't get this right in my implementation. So yeah. So that's how it works. Okay. So as a implementer interpreter, you don't have control on the language syntax or language semantics. You have to look up the semantics of language and then implement it exactly like that. You don't have the luxury of doing unless you're designing your own language. Yeah, so that's where I failed.
So you could replicate all the bugs and
Yeah, exactly.
so what happens here exactly? It returns one.
No, it returns one. So let's see. If let me remove prints. Let's say f equal to full print dot get x. Okay. So let's say Python c.py and this is one. That's wrong. That's one thing. Other thing is, I mean, it's been a long time getting the inheritance working. And function calls. Okay. Inheritance is because that's not in the language, so I have to implement getAttr, which actually looks at the class, finds the attribute in the object. If it's not there, then go and find in the class. If it's a function, then you actually have to give a bound function, right? So if it's a so when I say f of x and f dot get x, okay, the behavior is not exactly the same. When I say f of x, that just takes what's in the class and gives it. It's a get x, it doesn't give the same function. One function with one argument already supplied to it automatically. Right? I don't pass self explicitly when I'm calling get x, right? Just call it as like this. Okay. So it shouldn't give me the same function. It shouldn't give a function which takes one argument. It should give me a function which takes no arguments. So it should do a transformation before giving it. So that's a bit hard part. Okay. The other hard part is Python has its variable arguments and default arguments and how to all those things, right? Let's say look at f add or implement. Okay, takes x, and then step equal to 1. Return x plus step. Now I can say print increment of 5 or increment of 5 count. Right. Now it has so this is a default arguments. Now my core language doesn't have anything called default arguments and all that. So how will that work? That has to be done at the function level. Okay. So what it does is the issue with this. So that's where I need to explain all these things. Okay. So it basically creates the core language function takes 2 arguments, x and step. Okay. And then looks like this. Okay. And then the make func, what it does, it takes a function name, it takes names of the arguments in the default values.
Can you show the C.py once again?
Okay. Let me show that. Yeah. This is a step equal to 1. Okay. So in the core language, there is no concept of default arguments. So what it does, it actually creates a function that takes 2 arguments, and then done this. Okay. Now And when say increment, that actually calls the function makefunc. What it does is it takes that function and then all the set of metadata and then creates a function object. So function object has name, the names of the arguments, and then what are the default arguments, and then so many other things. Okay, I'll talk about other things in a minute. But when you actually call increment, I don't call the core language apply. I call a function called apply and pass list of arguments to it. So what it does is internally, it looks at objects, looks at its default arguments and see how many arguments you have passed. If you pass less, then it adds to it and then, okay. So it basically converts it the call to the core function.
Okay.
This does the transformation. Consequence for apply is what it does. So
Otherwise, you usually use just apply.
no, otherwise just
Okay, you implement that logic into apply.
into apply. So consequence to make topic is actually C app in the core language. This is the applying the core language directly. But this is pretty print of my core language. Okay. Now you can actually have little. Okay, let's say it takes even startups. Okay, and then say retail. So what should the core language function take? How many arguments it should take? So this body actually acts to 3 different variables. The core language function should take 3 arguments. Okay. So when it issue with that, it says now this is the what's the name of the var. If there's any var, then if I pass X arguments, then it should cut them off and then assign A and then pass. So this is again the hard part in the implementation. Okay.
So all that logic is in apply.
All the logic is in apply. So those are the 3 hard parts are getting the scope right, implementing the classes, and then these things, making the functions work right. I mean, I haven't implemented keyword arguments and then calling them with x equal to 1, y equal to 1. I haven't implemented all those things. Yeah, that's good. So, any questions?
That's cut off, right? No decorators, no meta classes.
Oh, decorators I have.
Decorators, yeah.
Okay. Yeah. Decorators is, it's actually,
Oh, actually it's easy, correct.
decorators is actually very easy. Okay.
It's a function,
Say-
function, yes, yes.
Food, okay. Or let's just say, it's called square. It's okay.
Only apply it here.
I just apply.
Which is apply to the function is not. Okay, the function itself is not.
Yeah, the function pass an argument. That's just a simple issue in this guy. Decorators is pretty damn simple though.
Yeah.
I just do issue them. I haven't implemented meta classes. I haven't implemented meta classes, I haven't implemented descriptors. Because, I mean, I kind of implemented descriptors mainly because I need to implement I think functions for something I implemented it partly but not completely.
You implement generators
No, generate expressions.
and then
Yeah. I don't have generators, I don't have generate expressions.
okay, so what do you do?
So,
Do we have a plug point here? Do we have a plug point? Plug point.
not it is a generator. Not it is an iterator in Python 3. So that's
Okay, if it were a list comprehension, you
I'm happy to leave this. That's easy. So now, I mean, you can do as many levels. So it's just once you have this.
You can write it from there and you won't get length, right?
So it's a double list comprehension. Okay, it's a bit tricky because multi-printing is not inventing very well. So now it's actually, if you see, it's a two-level map call. Okay. So you take, let me actually make it a bit more harder. So this one actually has access to a variable defined in the first for loop. Right?
Okay.
So what I need to do is, this function, this one, is called with vector x. Okay. Right? So range of x. So x is available here. Okay. And this function is what called by called here. Okay. So x into y is mapped by range. This one. Okay. So for this function, x is available in the upper scope. And then now, so I'm actually mapping. So basically I have two-level maps. Okay. So this one actually gives me an iterator, not just a single value. And then I'm mapping over that. So I actually have a iterator of iterators. So I call it interjoin. It basically takes each one of them and then flatten them out. Okay. So now let's see how it runs. Okay. Let's say.
Oh, right. You get an iterator where each element
Yeah.
is.
So for x equal to 0, this returns an iterator.
Yeah, I get it.
And then for x equal to 1, it returns one more iterator.
That's like your chaining thing.
Yeah, that's a chaining of things. That basically joins. When I have three things, it calls interjoin twice in the two levels. Okay, so this was not hard. The hard parts were getting scoping right and calling functions and all that. And I've tried to implement many things in Python. I tried as much as to move stuff into Python.
Keeping your code level small.
Code line is smaller, and even the built-in functions I try to implement as much as possible in the code in Python itself. Yeah, and if condition is calls a filter back. Filter. There is an if in the list comprehension generic expression. It calls a filter in the same way. Any other features that you'd like to see? How it's desugared? So the core is the cream of the implementation is in desugaring, right? So how do you desugar it in the core language? And core language is very easy to reason about. So there's less chance of making mistakes and all that. Any questions? So if we're done, then we'll actually discuss about what to do about Bangpypers website. So Grace